us see this topic of electric fields. This is one of AS physics topic. In this topic, we are going to see the whole concept of electric fields and electric field strengths. We'll also see how charged particles move in uniform electric fields. How charged particles move in uniform electric fields. So, all will say that objects are electrically neutral. It means objects are uncharged. Objects are electrically neutral. Always objects are electrically neutral. For example, even this paper is electrically neutral. This mark is electrically neutral. So always objects are electrically neutral or uncharged. But we can charge these by rubbing with another object. For example, this paper and this mark, we can rub like this. So it will be a transfer of electrons. So this will say the objects have been charged by separating positive and negative. So before continuing, we have two types of charges, which are positive charge and negative charge. So we say that this charge, if the charge are same, we say this charge repel. The like charges repel. Like charges repel. But the opposite charges attract. Attractive each other. Attractive each other. It's like this. For example, this is a see, if this is a positive and this is a negative, we found that there is attraction. But for the same charge, let's say for the same positive, there will be a repulsion. Positive and this is a positive. They repel each other. Also, for the same negative, there will be a repulsion. Repulsion. This is for negative, same negative charges, and this is for same positive charge. There is a repulsion. But for the opposite charge, positive and negative, there is attraction. So this is how charges behave. So let's say this is a uncharged object, which is positive, and negative. This is a charge. But if we rub with another object, let's say this is a cloth and this is a plastic. If we rub with this plastic, it means there will be a transfer of electrons. In an uncharged particle or object, always electrons will be the one which will be transferred, because these are not held strongly to the material. They are free to move. We say electrons are mobile, they can move. So these electrons or negative charged particles will be the one which will move to the another material, which is plastic. So here it means negative will move here. So this plastic material will be negatively charged. So we say now in this cross there is no negative charge. All negative charges have transferred to the plastic material. So this is how we can say now the object is not neutral, because it has been charged. it is a positive charge and this is negatively charged, and this whole process is known as electrostatic induction. Electrostatic induction. This is known as electrostatic induction. So, for example, let's say this is a positive plate and this is a negative plate. So we find that here there are some electric fields which will be formed. Like this. So electric fields will be like this, and the arrow will show that they are coming from positive to negative, and this direction also shows the direction of force in a field line. These arrows will show the direction of force, and always they are coming from positive. Always they are coming from positive. Let us see also for the repulsion of positive charge. To be like this. They're going away for the positive. So if it's a negative, it means the arrows are going inward. So these are known as electric field lines. These electric field lines. So here because these are electric field show the direction of force. So the electric field strength, let's say electric fields, these are electric fields is a field of force. It's a field of force created by electric charge. Created by electric charge. Electric fields is a field of force created by electric charge and can be represented by electric fields. Can be represented by electric fields like this. So here you can also find that there is electric field strength, which is represented by letter E. Electric field strength, which is force per unit charge. Force per charge. Electric field strength, we say this is the force per, this is the force per unit charge exerted by only a stationary positive charge. On a stationary positive charge. Positive charge. Electric field strength is a force kinetic charge exerted on a stationary positive charge. So electric field strength is equal to force over positive charge. So the unit of electric field strength for the force is the Newton, for the charge is Coulomb. So the units of electric field strength, its unit is Newton per Coulomb. Newton per Coulomb. So let us see the strength of a uniform field. The strength of a uniform field. Let's say we connect plates. Two plates which are separated by D. You connect to a high voltage power supply. Let's say this here, high voltage power supply. Connect here, positive and negative. So we connect to these plates which are positive and negative. We found that some electric fields will be formed. Electric fields will be formed, and here is a potential difference V. So here, so in this case we say that if we connect these plates in a high voltage power supply, we say that the higher the voltage is the higher the electric field strength. So V is direct proportional to electric field strength. But remember, D is the separation of these two plates, charge plates. So if we widen this, we increase D, it means electric field strength will decrease. Electric field strength will decrease if we increase D. It means we widen these plates. So we say electric field strength is inversely proportional to D. This is inversely proportional to D. And so by combining here, we find that E is direct proportional to V and inverse proportional to D. And then we also put negative here. This negative indicates that because fields move this direction as the arrow shows, and the force move in this direction. So we say that Negative sign shows that V increases toward the left, toward the right. V increases toward the right. From here to the right, and while the force acts in the opposite direction. The force acts in the opposite direction. So V increases towards to the side of high voltage power supply, but the direction of force is the same with the direction of field lines. So it is away to the left and the V to the right. That's why this is negative. So E, we say, is equal to minus V over D. But in calculation, we always take magnitude. So we'll leave with we remove negative this sign, negative sign. We take only the magnitude. So the formula will be E is equal to D. Electric field strength is equal to electric potential over distance of separation between these plates. This is V, electric potential difference between two charged plates. So now let us find the units from this relation. Units of electric field strength. So the unit for V is volts, and for D is meter. So here the electric field strength, its unit is volt per meter. But remember, also V is given by force over charge. So electric field strength also is given by Newton per coulombs. So the force over charge. So we find that 1 volt per meter is equal to 1 Newton per coulomb. Because electric field strength is equal to F over charge, and also electric field strength is equal to volts or potential difference over distance of separation. This question. Two metal plates are separated by a distance d. The potential difference between the plate is V. A positive charge Q is pulled at a constant speed with a constant force F from the negative plate all the way to the positive plate. Using the definition for electric field strength and the concept of work done, show that the magnitude of electric field strength E is given by this equation, which is E is equal to V over D. So they say that this is the potential difference two plates. So electric field strength, and this is a positive charge, which its force is in this direction, the same direction of electric field lines. Okay, so here, and the separation of these plates is D. So we say that how to use the concept of work done. Here we say work done is equal to NH transformed. NH transformed. Work done is equal to NH transformed. So our work done here would be equal to, always work done is equal to force times the perpendicular distance. So force times distance will be equal to LH transformed. Here will be, because you have charge, you have electric potential energy. No, we have electric potential difference. So it will be V is equal to V times charge. Okay. So now, okay. So work done is given by force times distance, and the energy transformed is potential difference, electric potential difference times charge. So dividing by charge here, we found that V is given by, we found that F over charge is given by V over D. So force per unit charge is electric field strength. So V over D. V over D. So this is the equation we are required to show. This is the equation we are required to show. So let us see this question as an example, how to use electric field formula, electric field strength formula to calculate the questions. Okay, two parallel plates separated by this centimeter have potential difference of 5 kilovolts. Calculate the electric force acting on a dusty particle between the plates that have a charge of 8 times 10 by negative 19 coulombs. So our solution. So what we have here is D, which is 2 centimeter. So I have to convert it into meter, which will be times 10 minus 2 meter. And also we have electric potential difference, which is 5 times 10 volts. So we have given this distance and volts. So we have to calculate the electric force. But we have two formulas of electric field strength. One is E is equal to force over charge. Force over charge. And also here I have given a charge, which is 8 times 10 minus 19 coulombs. But we don't have electric field strength. So another formula for the electric field strength is V over D. So we can find electric field strength, or we can rewrite this, that F over charge is equal to potential difference over D. So we can find force by taking potential difference times charge over distance of separation. So our force now will be equal to, our potential difference is 5 times 10, 3 times our charge here is 8 times 10 minus 18 over separation is 2 times 10 is 2 meter. So we get here in Newton. So by calculating this, we find force in Newton. So let us see a force on a charge in a uniform field. So this is a uniform field, and here is our electron, a charge, is entering in a space of a uniform field. So if this charge will enter here, to find that because here is negative, this plate is negative charged, so it means here our electron also is a negative charge, so there is a repulsion. This negative plate will push that electron down, so our charge will move like this way. So say this is a parabolic path. So say an electron charge moving initial at right angle to a uniform field, electric field, follows a parabolic path. Follows a parabolic path. So now let us find the force here. From electric field strength, which is given by V over D. But remember the negative sign, which stands for the which is the V is opposite to the force which moves in the same as the electric field strength, the electric field lines. So from this relation, E is equal to minus V over D, and also from E is equal to force per unit charge. So we can rewrite here force over charge is equal to minus V over D. Now D here is separation of these two plates, positive plate and negative plate. So our force here will be times charge both sides. We found that here minus V over times charge over D. But here for electron, for charge is minus E. So here our force will be equal to E V over D. So this is a force on a charge in a uniform field. This is a force on a charge in a uniform field.